Welcome to Algebra 2 reviewing for our first semester final exam. This topic is on graphing lines, finding the slope-intercept form, standard form, slope, x-intercept, y-intercept, and then the graph. First, I'm just going to refresh you as to what the slope-intercept form and standard form is. Slope-intercept form is y equals mx plus b, where m stands for our slope and b stands for our y-intercept. Standard form is ax plus by equals c, where a, b, and c are integers with a greatest common factor of 1. So they can't be simplified down at all. And a also should be positive, so a should be greater than or equal to 0. And then there's one other form that's going to be useful for us, and that is our point slope form. Point slope form is y minus y1 equals m times x minus x1. Oftentimes, we have to use this form to get it into one of the other two. So here we pass through the point 4, 8 at negative 2, 1. All right, so a great first way to start this is to graph the two lines, or the 2 points. So here we're going to graph 4, 8. So there's 4, 8, and then negative 2, 1. You're going to take a straight edge or a ruler and connect those 2 points together and draw in a beautiful line. Once we have that, we can certainly go ahead and find the slope between the 2 points by using our slope formula, which is y2 minus y1 over x2 minus x1. So here, this would be 8 minus 1 over 4 minus a negative 2, which then gives us 7 over 6. So this is our slope. Now that we have the slope, we can use the slope that we have with one of the points. I'm going to choose 4, 8, and we can put it over here into point slope form. So y minus 8 is equal to 7, 6 times x minus 4. So once when we're here, if we get the y alone, that then is our slope-intercept form. So we'll distribute the 7, 6 throughout. So y minus 8 is equal to 7, 6x minus 14 thirds, because 7, 6 times 4 over 1. The 4 and the 6 could each be divided by 2, so we change it to 2 and a 3. 7 times 2 is 14, and then over 3. And the only thing we have left to do to get the y alone is to add the 8. So that gives us y equals 7, 6x. And then we have to take negative 14 thirds plus 8. Well, if we want to write 8 as in thirds, it would be plus 24 thirds. So this would then be a plus 10 thirds. So that would be our slope-intercept form. Okay, then if we want to get it to standard form, these have to be integers. So we cannot have these denominators in here. So what we're going to do is we're going to multiply both sides of the equation by the least common multiple of 3 and 6, which in this case is 6. So we're going to multiply both sides of the equation by 6. That would give us 6y equals 7x plus 20. We need the x on the other side, so we'll subtract our 7x. So now we have negative 7x plus 6y equals 20. And our first value, a, it has to be positive. So now we're going to take our equation and times it by negative 1 on both sides. That gives us a standard form of 7x minus 6y is equal to negative 20. So there we have our slope-intercept form and our standard form. We also need to identify the x-intercept and the y-intercept. Well, the x-intercept, you just have to take from your standard form, you're going to envision crossing off the x values and then leaving the equation with just the y's, and that gives you your y-intercept. So negative 6y equals negative 20 divided by negative 6. Negative 20 divided by negative 6 is a positive 10 thirds for your y-intercept. That also matches what our y-intercept was in the slope-intercept form. So now to find our x-intercept, we do a similar thing, except for this time we're going to envision crossing off the y's, leaving the 7x equal to the negative 20, dividing both sides by 7. So our x-intercept here would be negative 27ths. And last but not least, the slope, which we have already found to be 7, 6. This is an ugly problem with ugly fractions, but your problems on the final would not be like this one. they would have much easier numbers to work with.